Algebra 2 Honors Lesson 8.4 Properties of Logarithms. The lesson's objectives apply the product, quotient, and power property to expand and condense logs. Okay, so the first thing, let's talk about the three properties of logarithms. The first one I'll talk about, alright, is the product property. Okay, the product property. Now the product property, basically it's used to expand logarithms. Okay, over here we have a single logarithm. Okay, now when you expand it, what you're doing is you're separating it into multiple logarithms. Okay, that's called expanding. Now over here you notice here log base b, and then the result here we have kind of like a two terms for the result. Okay, we have two terms, alright, two values for the result, alright, that are being multiplied with each other, right? So if they're being multiplied with each other, well, let's say for example we have the m and the n, right? So when you expand this, you have log base b of m, alright, plus log base b of n. Okay, so the two values of the result, alright, the two terms here, they get separated when we're separating the logs. Okay, and what happens is both of these logs here, you notice, are positive. Like there's a plus in front of this log. Over here we don't put the plus, but we know it's positive. The reason why these are positive logs is because this right here, if you put it over 1, right, let's pretend this is a fraction. What I want you to remember is anything in the numerator of the result right here, anything in the numerator, alright, that means that their logs will be positive. Okay, so for example, say we had this log base 2 of 3x. Okay, now 3x is the same thing as 3x over 1, so the 3 and the x is are in the numerator, right? So when you expand this, you're gonna have log base 2, alright, because it's a base 2 log base 2 of 3 plus log base 2 of x, because the 3 and the x they were separate terms being multiplied with each other. Okay, so here's a single log, we've expanded it. Okay, let's try another one real quick. Log base 4 of, let's say, 2xy. Alright, so when you expand this, now you're gonna have log base 4 of 2 plus log base 4 of x plus log base 4 of y. Okay, notice all these logs are positive because 2xy here, you put this over 1, all these values are in the numerator. Okay, now let's talk about the quotient property. The quotient property is when there's a division going on here, right? So you have a numerator and a denominator here. Now you notice here the m, alright, the result here, the m is in the numerator, so the log was positive. Over here the n is in the denominator, so the log is negative. Okay, so the n here is in the denominator, so that makes this log negative, right? So for example, we have something like, let's say log 2x log 2x over y. Okay, so if we expand this, alright, so let's take a look at the top here first. So we have log base 2, right, and then plus, log base 10 of 2, log base 10, alright, well you don't need to write the 10, okay, of x, and then since this y is in the denominator, it's going to be a minus, alright, log base 10 of y. Okay, so the quotient property, anything in the, for the result, any values in the denominator, that means that its log must be negative. Alright, let's try another one. Let's say we have log x over 3y. So if we're going to expand this, we'll have log base 10 of x, positive because the x is in the numerator, and then the 3 and the y alright, is in the denominator, so when you expand it, we have log base 10 of 3, alright, and the log is negative, and the next one is also going to be negative, alright, log base 10 of y. Alright, now both of these are negative because both the 3 and the y right here are in the denominator. Okay? And keep in mind, another way to write this would be log base x. Now you can write these separate like this, or you can just write it minus log 3y, but you would have to put this in parentheses right here. Okay? But the best way is to just, expand them, break them down separately too. Occasionally you might see it written like this. Alright, these mean the same thing. But the best way is to just completely expand everything. Okay? And then the last property is the power property. Okay, the power property. When we talk about power, alright, we're talking about an exponent. Alright? So if the result has an exponent, okay, when you expand it, this exponent gets moved to the front of the log. Alright, when you're expanding. Okay? So let's say, for example, we have log base 3 of x squared. When you expand this 2 gets moved to the front of the log. Alright? It gets moved to the front of the log. And then you have log base 3 of x. Okay? So keep in mind, anytime you see a value in front of a log, that tells you that this value is really the exponent for this result. Okay, it's really the exponent for this result. Let's try another one real quick. Let's say we have 2x to the third. Okay, so we're expanding this. Now you notice here, this 3, the base of this 3, it only is only the x, right? This exponent only applies to the x. So when you're expanding this, you have log base 10 of 2, right? Log base 10 of 2. And then we have plus, because both of these are in the numerator, right? The 3 goes to the front of the log, because that's the exponent. We have log base 10 of x. Okay? So there you go. So it's really important to understand, like, the base of an exponent and, what the exponent actually belongs to when you're expanding and condensing. Okay? Because there's a 3 here, but there's not a 3 here. Alright? Because it's not 2 to the third power, it's just 2. That's why you should not have a 3 here. Alright? So those are the 3 properties of logarithms. Now keep in mind, I showed you them all separately, one by one. But most of the time, you're going to use 2, if not all 3 properties together in one single problem to expand and condense. For example, let's say you're asked to expand log 3 over xy squared. Okay, let's say we need to expand this. So first of all, we have log base 10 of 3. Alright, this is positive because 3 is in the numerator. Then these are in the denominator, so you know where you have a minus sign. Now this 2 only goes to the, the exponent 2 here only, the base is y, it only goes to the y, so you have minus log base 10 of x, and then minus 2 log base 10 of y. Alright, so you notice these 2 logs are negative because these values in the denominator, and this exponent 2 only belongs to the y. That's why there's a 2 in front of the log y here, alright, and not also over here. Okay, so that's expanding. Now you're gonna have to be able to expand with radicals also too. Let's say we have, let's say they want you to expand 3 square roots x over 4. Okay, in order to expand this, well, the first thing you want to do is remember in chapter 7, if this is in radical form, you want to change this right here to exponent form. In exponent form, this would be x to the 1/2 power, right? So once you've changed this to exponent form, just apply the properties. So we have log, base 10 of 3 then you have plus 1/2, right? Exponents get moved to the front of the log. 1/2 log, alright, base 10 of x. And then the 4 is on the bottom, so you know that's going to be minus log base 10 of 4. Okay, so if you happen to have radicals, change them to exponent form, right? And you guys learned that in chapter 7, and then use the properties. All right, let's do one more with radicals. Let's say expand to cube root x y squared over c to the third. Okay, well, the first thing you want to do is you want to change all this to exponent form, right? So this is going to be x to the 1/3 right here, y to the 2/3 over, and then z to the third. And then let's expand this now, so we're going to end up with log, we have the 2 here, 2 plus 1/3 log x plus 2/3 log y. All right, all of these are positive because all these values are in the numerator, right? The exponents get moved to the front of the log. And then the z is on the bottom, so that makes the log negative. All right, 3 goes in front of the log base 10 of z. Okay? So that's expanding. Now we're going to have to also go in reverse too. Meaning, if they give you a single log, we've been expanding. Now if they give you the log, the log expanded, you have to be able to condense it, or write as a single log. So we usually call it condensing or shrinking. Right? I think the book might say, just write as a single log. So let's say we have something like 1/2 log x plus log 3 minus 4 log y. Alright, so it's expanded here. Now we need to write this as a single logarithm. Okay, now first of all, alright, so we have the 1/2 here in front of the log. That means this is really the exponent for this x here, right? So let's write a single log. That makes it that, and this is positive, right? So this is x to the 1/2. This is also positive, so you know this is on top of the, in the numerator. And then if this is negative, you know that this is really the exponent for this. So this is y to the 4th. And then you should change this to a radical form, right? If this is x to the 1/2, this is really just a square root of x. So the final answer and the correct way to write this would be 3 square root x over y to the 4th. Okay? So all we're doing is we're just working backwards now. All right, let's try another condensing one. Let's say, for example, we have 2/3 log x minus 4 log y minus 1/2 log 5. Okay, so let's write this as a single log. So we know these values in front of the log are really these exponents. Alright, x to the 2/3 power. Alright, then these are negative, so you know that these go on the denominator of the result. So you're gonna have y to the 4th and also 5 to the 1/2 power. So let's write this the correct way in radical form. This would be the cube root, right, of x squared over, this looks like this would be the square root of 5. So y to the 4th square root 5. Okay, and then you don't need to worry about rationalizing denominators or anything like that when you're condensing, or shrinking, working with a logarithm. Just keep it like this. That's fine. Right? No need to rationalize or anything like that. Alright, so that's how you condense logarithms. Okay, so just applying the stuff you learned in chapter 7, the exponent rules, right? How to convert back and forth between radical and exponent form, all right, with the new properties that you just learned in chapter 8. Okay. Now let's talk about evaluating, which we did a little bit in the last lesson. But what did they give you? The problem such as 2 log base 8 of 4 minus 1/3 log base 8 of 8. Alright. So if the first thing you need to understand is, look, this is expanded in expanded form. Okay, so what you need to do first is you need to shrink it into one single log, all right, in order to evaluate it. So you need to condense this into a single log. So log base 8. All right. So remember, when you're condensing, okay, you have to have the exact same base logs. Okay, so both of these are log base 8, so we're okay. So this would be 4 squared, right? Over, so this is minus, so you know this goes in the denominator. So we have 8 right here to the 1/3 power. Alright, and then simplify this. So this is really log base 8. Alright, log base 8. 4 squared is 16. Alright, 8 to the 1/3 power is the cube root of 8. Right, the cube root of 8. What's the cube root of 8? The cube root of 8, alright, the cube root of 8 is 2. So you're going to end up with log base 8. Alright, 16 divided by 2 is 8. And you can set this up if you want, but it should be pretty obvious. Remember, we talked about this in the last lesson. If the base and the result are the same, that means that the exponent has to be positive 1, right? It has to be positive 1. Okay? Let's try another one. Alright, let's try another evaluating problem. Let's say we have 2 log base 8 of 4 minus 1/3 log base 8 of 1. So let's condense this real quick. We end up with log base 8 4 squared over 1 to the 1/3, right? So it's pretty similar to the last one, but if you work this out, basically you end up with 16 over here over the cube root of 1, which is 1. So you end up with log base 8, alright, of 16. Now the numbers here aren't so nice, right? So remember, like we did in the first, alright, lesson in 8.3, what you guys learned. If the numbers aren't so nice, remember, if you need to figure out what the exponent is going to be, just change this to exponent form, and then what you're trying to do next here, right? What you're trying to do next is you're trying to get the same base. So 8 is 2 to the 3rd. X is equal to 16, which is 2 to the 4th. So 2 to the 3x is equal to 2 to the 4th. So now that you have the same base, it's okay to set the exponents equal to each other. So x is going to equal 4/3. Okay, and you guys did all this stuff in lesson 8.3, right? The only thing new here is we're condensing first, right? The only thing new in this lesson right here is you need to condense first, and then, right, after you condense, then you evaluate the log. Okay. Let's see. Let's try one more evaluating one. Let's see, we're gonna have log base 2 4 minus log base 2 of 16. So let's condense this guy first right here. Okay, so we have log, so this would be 4, that's minus, so we're dividing, and then the 16 is going to the denominator, right? It's a base 2, so log base 2, 4 divided by 16, that reduces to 1/4. Okay, so 2 to what power is going to give you 1/4? Well, let's change to exponent form. Alright, since the numbers aren't quite so nice. So right here, 1/4, remember you want to change this so that it's not a fraction. So let's rewrite this so that it's not a fraction. That's the equivalent of 4 to the negative 1 power. Okay, so then you end up with 2 to the x is equal to 4 is 2 squared because we need to get the same base. So I'll give you 2 to the negative 2, 2x. If you've got the same base, it's okay to set the exponents equal to each other, so x is equal to negative 2. Okay. Now the last thing we'll talk about is without using a calculator, we need to evaluate some logarithms. Now let's say it's given that we know, alright, log base 10 of 4 is equal to 0.6021. Alright, and we also, it's given that log 5 is equal to 0.6990, and log 6 is equal to 0.7782. Okay, so these values are given to you. Okay, now let's say they tell you to evaluate. Alright, let's say they want you to find out, alright, evaluate what log 30 is. Alright, so without using a calculator, what you have to be able to do is, using these values that they give you, you have to think, so you have a 4 to work with, a 5, and a 6. Using exponent rules and multiplication and division, how can you somehow end up with 30 with the values 4, 5, and 6? Well, 30 is basically log base 10 of 5 times 6. Alright, you have two values, like 5 times 6. That gives you 30. Right, you're just breaking this down, and you can break it down any different way you want, as long as it gives you 30. Alright, there's going to be different ways to break this down. So once you've broken this down, what you want to do is you want to expand this. Alright, once you've broken this number down, you want to expand this logarithm. So this is the equivalent of log base 10 of 5 plus log base 10 of 6, right? And then what you want to do is next is you're going to substitute these values. Log base 10 of 5 is given to us that it's 0.6990, plus log base 10 of 6 we know is 0.7782. So now you're just adding these decimals here. So if you add the decimals, okay, you're going to end up with 1.4772 as your answer. Okay, now the key here is to make sure you expand this right here, expand this before you substitute in these values. Okay, well, the mistake I'll see is students will break this down and then they'll substitute the 5 and the 6 right here, the log 5 and log 6. They'll substitute these values into here and think that they're supposed to multiply the values. Alright, that's incorrect. You want to expand this first and then substitute in these decimals. Okay, let's try another one. We're going to use the same values, 4, 5, and 6. Let's say log 80. Okay. Now using 4, 5, 6, how do we somehow get 80? Alright, how do we somehow get 80? Well, this is log. Alright, and sometimes it might be kind of difficult to see. Sometimes you just have to get used to it. 80, well, that's, if we do 4 squared, right? 4 squared is 16. 16 times 5, that gives you 80. Right? 16 times 5 gives you 80. Right? So you can only use these values that are given to you, and somehow you have to try and figure out, all right, how do I end up with 80? Okay? So then now what we're going to do is we're going to expand this using the the properties that we learned. So you have an exponent here, so that doesn't go in front. We have 2 log 4 plus log 5. After you've expanded, now you want to substitute in the values. So you have the 2 in the front here. You're multiplying it with log 4, which we know is 0.6021. Alright, 0.6021. Alright, plus log 5 here, log 5, which is 0.6990. Alright, 0.6990. And then all you're going to do is you're going to just take the 0.6021. Alright, you're going to take the 0.6021 and you're going to multiply it, alright, times 2. So 0.6021, you're going to multiply it times 2, and that's going to give you 1.2042. Then you're going to add that with a 0.6990, right? And then that's going to give you your final answer, 0.6990. So 190.32. So our final answer is going to be 1.9032. Okay? Let's try one last one. Let's make this one a little bit different. So we're asked to evaluate. Let's make this one a fraction. Let's say 1 over, let's say 125. Okay? 1 over 125. So first of all, you want to write this so that it's not a fraction, right? So this is the equivalent of 125 to the negative 1 power, right? Now 125, remember you only use the values 4, 5, and 6. We know this is right here 5 to the third. 5 to the third gives you this, right? Then you have the negative. So follow the exponent rules. You end up with 5 to the negative third power. Alright. So now you're going to expand this. So this is going to become negative 3 log 5. Once you've expanded it, now you're going to substitute in the values. So you have negative 3 log 5, we know is 0.6990. Right? So all you have to do is take negative 3 times 6.990, and then that's going to give you your answer. So we're going to end up with negative 3 times 0.6990, and your answer is negative 2.097. And that is your answer. Okay? So that's how you evaluate logarithms if you are given logarithm values to work with and you are not allowed to use a calculator. Alright?